All right, so let's continue with these thoughts on energies associated with reactions, and let's talk about exothermic and endothermic reactions. So we said that when we have reactions, the potential energy associated with the reactants is most likely different than the potential energy associated with the products, and that difference in energy determines if energy is released during the reaction or energy is absorbed during the reaction. So we can tell this using the heat of reaction, the delta H. And remember, delta H is the potential energy of the products minus the potential energy of the reactants. So if we find that delta H is less than 0, is negative, if the heat of the reaction is negative, that means that the potential energy of the products is less than the potential energy of the reactants. So when I subtract the two, I get a negative value. When that happens, during the reaction process, because there's excess energy, it's released as heat, typically as heat. That means the local surroundings absorb some energy as heat as the reaction process goes on. Okay, so in our diagram here, this is called an energy diagram. It shows you how the energy changes as the reaction goes on. We can see our reactants at a certain energy here, and the products are at a lower energy. That makes the delta H of the reaction, because we do energy of products minus energy of reactants. If the reactants is higher, the value is negative. You can see our difference it drops, so it's negative. That means heat's released during the reaction. So when we have that, it's called an exothermic reaction. So when delta H of a reaction is negative, the reaction is said to be exothermic. And I think of it as EX, it means exit. It means energy is exiting. So if we look at our reaction down here, this is the combustion of propane. During that process, propane is reacted with oxygen and produces carbon dioxide molecules and water molecules. Because this is exothermic and heat is released, we're going to show that heat is a product, right? So heat comes out of the reaction, so heat is a product. And if we look at this reaction, for 1 mole of propane, if we combust 1 mole of propane, we will produce 2010 kilojoules of energy. It's negative, which means that it's released. If you see negative, it means it's released. And that just implies that this difference, the difference between the potential energy of the reactants and the potential energy of the products, is 2010 kilojoules. Okay. On the other side, if we have delta H being positive, meaning that the energy of the reactants or the energy of the products is higher than the energy of the reactants, that means during the process, if we look at our energy graph here, during the process, I have to put energy into the system. Because the potential energy of the products is higher, that means they have to absorb energy from the surroundings, whatever it is. If they're in water or whatever, they take energy from the surroundings to get to products. So that means during the process, some sort of energy, heat typically, has to enter the reaction so that we can get to products from our reactants. An example of this is the decomposition of aluminum oxide. We show, when we have endothermic reactions, we show that the heat has to go as part of the reactants, because in order to get to products, we need to put heat into the system, okay, into the reaction. So in these cases, for endothermic reactions, when delta H is greater than 0, we're going to put heat, if we show it, we're going to put the heat in the reactant side. Okay. In this case, delta H of this reaction is 1,676 kilojoules per mole. It means for every mole of aluminum oxide that reacts, that decomposes, we need 1,676 kilojoules of energy. And that's the difference between reactants and products. That's that space between the two that if we have 1 mole of aluminum oxide, to get to products, the aluminum metal and the oxygen, we need to put in 1,676 kilojoules of energy. Okay, the positive there means that the products have more energy than the reactants, so that means we have to put energy in. Negative, if delta H is negative, energy is being released. If delta H is positive, energy is being put into the reaction.